Welcome to Sravz Technical Series. In today's session, we'll continue Golang crash course discussion. We already discussed two sessions. In session 1, we discussed the development environment setup, Docker Compose, VS Code, Cider version, and development environment setup. And then in session 2, we went through the project structure, go.mod file, sound file, go.mod.id, go.mod.vendor, etc. In today's discussion, so in the previous session, I showed how to run the application. So once you run A, it will build the application and then it will run in the background. And then we went through the main.go file. The main.go file has the main package name. So if it's an executable package in Golang, it has to have a main package. So we have main package and then the main function. And then in the main function, we discussed all of these lines and we set aside the router middleware methods. So today we'll go at a high level what a middleware means in Gorilla Mux. But this session is not about Gorilla Mux. It's just a gentle introduction to what a middleware means in Gorilla Mux. So, as you know, most of the HTTP pipelines, be it in ASP.NET Core or Django, etc., it's all based on a pipeline. So you get a request object. The request object is sent through the controller, which process the request and then generates the response, and then this response is sent to the browser. So this is a pipeline. This pipeline, you can set up some functions in this pipeline which act like a middleware. For example, when you get a request, even before a controller picks up that request, if you want to do some validation, for example, say JWT token, Java Web Token validation, you can add a middleware. A middleware is just a function. So these functions will process the request, and only if that function determines that the request is good, for example, if it's a JWT token, if it finds out the JWT token is valid, then this function will return true and then the pipeline continues. If the function determines that it's not the correct request, then we short circuit the request here, for example like this, and then we send back the response. So it's called a pipeline process. So the same concept is used even in Node.js Express. So Gorilla Mux also implements something similar. So these middlewares are a set of functions which are executed before the controllers are called. So to demonstrate Golang concepts, I put in some middlewares here. So when we go to the packages directory, we'll discuss these middlewares. So that's what the middlewares are doing. And then we discuss the Go keyword, which implies it starts a Go routine. A Go routine runs on a separate thread. So with that, let's continue the discussion of this Go routine. So I set a rate limiter concept in Go. So once the HTTP request comes in and we are doing the HTTP request and response handling, we have set up a rate limiter in Golang. So this function runs on a separate thread because it's a Go routine. And then in that function, for every 1 millisecond, tick.tick, time.Tick gives us a channel of time.time. So every 1 millisecond from this channel, we get a tick. So this channel returns every 1 millisecond. So for every 1 millisecond, we send the timer into this limiter channel. So this is a channel of type time.Time. So in Golang, channels are a messaging queue, you could say. If you have gone through the C++ course we have discussed in the past. So for example, in the C++ section somewhere, use REST API. Yeah. If you look at this whole, we created a single producer, single consumer, SPSC, single producer, single consumer queue. So you can think of a channel as a queue between two separate threads. And these threads would be waiting for messages on that queue. So channel is similar to a queue where one thread would send a message and the other thread would be waiting for a message on that queue. So once the channel in the main.go, so every 1 millisecond we are sending the timestamp to this channel, and in the rate limiter middleware, which we put here, rate limiter middleware, we have a go function. Go to definition. So here we have a go function. It's a middleware, and the middleware naturally run in a separate thread. So that's why we didn't start a go routine here. So in the middleware, we wait for the rate limiter channel. So we are reading arrow away implies we are reading from the channel, and we are not storing the time anywhere. We could put underscore equal to. Underscore implies we don't need to do anything with that value, or you could just remove that underscore equal and just leave it like this. That means read from the channel but don't do anything with it. So for every 1 millisecond, this will become a blocking line. For every 1 millisecond. So that way we are processing the request after every 1 millisecond. So this way we are rate limiting our HTTP server. So this is a concept. So we use this middleware to demonstrate the concept of channels and how inter-process communication happens between, not inter-process, inter-thread, inter-go-routine communication happens between two go-routines in Golang. So that's about the middleware channel, middleware rate limiter middleware. So once we set the rate limiter here, then we started the HTTP server, which we discussed in the previous session. And then we go to the, then we start the HTTP server. We started the HTTP server in a separate thread by using Go function call. So it's a separate Go routine. And then we set up a cron job. A cron job is nothing but some thread which runs every certain time in the background. So we'll go to the background function. So we set up a cron job. So here we are discussing again channels and threads, go routines. Again, go routines and channels discussion. So background is a function which we are calling in a go routine. It's not a go routine, we just call the function. In the function, we'll start the go routines. So if you recall from the first session, we get tickers from a location. So we have to run this function every certain time to refresh the current prices of Bitcoin and Ethereum in our in a map. So we call this function in the background at every certain time. So I'll go back to the background function. So in the background, once we call this function, we get tickers. After we get the tickers first time, we start the new ticker which expires every 10 seconds. Every 10 seconds, the ticker will be a ticker will contain a channel into which we get a time every 10 seconds. So in a separate thread, in a separate coroutine, using for range channel, for range when declared on a channel, it will loop forever and keep on waiting for the messages on the channel. So every 10 seconds, using for range, we wait for a message, which is the timestamp, on the ticker channel. And once we get a message, we call get tickers again. So we get the tickers first time, and every 10 seconds, we get tickers again. So this is a continuous loop. And since it's a Go routine, the thread which calls this function will proceed. This will run in a separate thread. So we created a channel, wait for a message on the channel every 10 seconds, and then we are refreshing the tickers. So in this concept, we showed how to run a background cron job in a HTTP server, so that the HTTP server will refresh its cache of ticker information, so it can send that to the browser whenever there's a request. Similarly, we have another function in which we set up the logger. So in the same background thread, we created another Go routine called logger this time, and we created a config structure in config package. So we have a config structure in config package config, where we have another channel for logs. So it's a string channel. It's a message queue of type string. It's called log channel, into which somewhere else in the program we will send messages, string messages. So in this background thread, we are waiting for the string messages on that channel or a message queue using range again, and we're just doing log print of that message. So this is how we have set up a message. So somewhere in the program, something will send a message over the string type channel, and here this coroutine will print that to the console. And this is another concept in Golang, the usage of select. So we already know what a channel means. So we have two channels now. Now using select, we can wait on multiple channels. Here using range, we were waiting on only a single channel. But here, we can wait on multiple channels. So it's called a stateful Go routine. So whenever there's a message in either of these channels, we print it, or else the select will block. The select will block for some message to come here. If you have a default, for example, if I put default here and save it, run, it's building. I'll cancel it out and do it again. So in that case, select will constantly print no middleware is ready, because it does a busy wait on these two channels and print the log messages. So now I put a default here. So the select is doing a busy wait on these channels, but there's no message on these two channels. But we have a message here, so it's printing this message in a loop. So So that shows that's why with select we can wait on multiple channels. We'll go back to the main.code. So we discussed the background today. In the next session, we'll discuss the interfaces and structures and also use of generics and then use of another concept called context and then defer. So these are other concepts in Golang. We'll discuss those. And since we have discussed main.go in a little bit details, when we go through the packages, it'll become more clear. And then when we discuss the packages, we'll again retouch the channels concept, and it will become more clear at that point. And also our middlewares are printing a lot of information here. For example, when I go to say call a test endpoint, so I'll call this one send. All our middlewares are logging information. So we'll go through these log messages when we go through the packages or the middleware functions. So with that, I'll conclude this session for today. If you have any questions, please reach me out in the YouTube channel or in the documentation discussion page, which is here in the bottom. Thank you for watching.